Thank you for the organizer for inviting me to speak at this conference. I enjoyed the presentation Professor Wu made. It's very interesting. It's amazing. Okay, I'm going to proceed my own presentation. Respiratory masks for combat COVID-19 pandemic and public health care. I'm from the City University. Probably not everyone knows this university very well because this is actually a very new university. It's 26 years old, but it's now ranked number 4 in top 50 university under 50, and it's world for top 50, one of the top 50 universities in in the world according to QS ranking. It is the number 1 most international university by Times Higher Education, and we have um, a lot of talents, dedicated scientists in academic publications. We also ranked the 16th Asian University ranking. I'm from the engineering school. It's number 1 in maybe Greater China, and my department is biomedical engineering. It's ranked at 23 in the world, and number 1 in Hong Kong. Okay, actually, I was in Hong Kong Polytechnic University for more than 20 years. Over there, I established a shared memory textile center, and we had the 3 areas of research. The core is the shared memory polymers, fibers, textiles, and now we are extending them to biomaterials and later. And then now in the City University of Hong Kong, I have established my work in the 3 major areas: Chinese medicine, NH wearables, and alternative therapies. I still work on shared memory materials, biomaterials, wearable electronics, and also working for materials for personal protection, respiratory masks, antimicrobial materials. This is because, of my past experience, and since the breakout of the pandemic, I was heavily interviewed by media to support the local industries and the public for respiratory masks related issues. Okay, if there are students, there are professors, you can also tell your students we have positions available in the laboratory of wearable materials for healthcare. We are in turmoil of infectious diseases. The COVID-19 infectious diseases. 5 years ago, Bill Gates has made a prediction. Warn us to really be aware of the disasters pandemic or epidemic can cause to our human race, and we need to be preventive. We need to take actions to respond to such emerging problems for our human being because of various problems. And pandemic is always the biggest problems, the biggest the risk in our human society. In human history, pandemic is always more destructive than war. For example, in the Black Death, it killed more than around 200 million people. It's huge. And also there's a record for Spanish flu. There also about 50 million deaths. In just amount 180 million people. It's not so long time ago, just 100 years ago. Now we encountered probably the biggest pandemic in our human history. Yeah, people have, a lot of people have commented that COVID-19 has much greater impact than the previous two world wars. And this is the, you know, say we really need to be very, uh, we need to be very active, responsive to this. And it, coronavirus, just like we can see from this picture, is just a very small material protein assembly. It's not even alive. So, but it has the life heritage, elements in its body. So it can be, it's very infectious. The transmission uh, mechanisms actually described in this picture. Um, there are two roads. One is that by droplets. The other one is by aerosols. Droplets are normally much bigger, so they can be transmitted within a very smaller distance. And with larger distance, they are aerosols. They carry the viruses, and then we can get infected through our respiratory systems. So yeah, here we have more clear picture about the transmission of the coronavirus. You can see when we speak, when we cough, when we have breathing, the virus is coming out with droplets, with aerosols, and they are embedded. They are normally embedded in bubble, in the particles, etc. So here also tell you from this side to the other side, the if a virus coming out, and then it can, with the droplets, it can come to the to many substances, to many objects, and this can be can get infected by contacting, and also this can be transmitted through our breathing system. Okay, this the transmission is witnessed by all of us for the pandemic transmission, and now so far the best and the most widely acceptable prevention for such COVID-19 is wear a mask. Wear a mask. The mask is a very small piece of textile device, but it has normally these three layers. This out layer can be used for water repelling, for actually the support, so that it can be durable. But this side, the filtering device is in the middle. It's specialized textile. It's called melt blowing, and the melt blowing has to be also treated by electric processing. And there's another layer which has a support for the durability and the function of the melt blown fabric, and also it should maintain the comfort to our human skin and the respiration needs. The more you wear, the early you wear the mask, the safer. The more separate. This is based on the separation, based on previous transmission principles. This if this one, if you don't wear, the risk is very high. If the receiver wears, if the infected person is not protected, is not prevented from spreading, the risk is still very high. And then if we, particularly for the sick, the person to wear the mask, the risk can be reduced significantly and then to the medium. And both, both people can wear masks. You can actually reduce the risk to low. And then if you keep a distance, we can have a very low. If we are separated from some others, you can be very safe. US, US has has a problem of almost the highest infection every day for so long time. Even though their politicians promote, but these are smaller politicians. The biggest politician is Trump. He's not very, he's actually not very careful with wearing masks. So U.S. has the biggest problem in this. Okay, and this is actually early data. It said that if you wear masks, the countries, places, their incidence, their infected incidence are much lower. If you don't wear, there's much higher infection. These are the data. Previously, they are just schematic. Yeah, and so face mask is the key. It's the key in defending ourselves from pandemic, from virus. So face mask is very important. It's the most important device in the past now probably almost 1 year. It's for some countries maybe half year. From China is almost 1 year already. Yeah, they have different materials. They have mechanisms. They have different evaluation methods. There are subjective ones. There are objective evaluation data. Particularly, this bacterial filtration efficiency, particle filtration efficiency, virus filtration efficiency, etc. And these are essential. These are actually probably prerequisite. However, it have not been very thoroughly stressed. I have introduced briefly in the previous slide on the structure and the function of the face masks. The most important thing is in the middle, but others are also very important. For example, here, the inner layer is to provide the support as well as the comfort, and this one is provided the protection from very big, from water, from some general protection. But this layer is particularly for filtration, particularly for the protective of virus and bacteria. And there are different types, probably you have heard of them, and there are different types of respiratory or face masks. This is by far the most important thing for the general public. This is public health. This is good for the professionals. These are also good for the professionals. And then there are actually many different terminologies. For example, respirator, surgical mask. Surgical mask they have some general specifications. Surgical mask is a normal mask for the hospital doctors to wear in their practices. The respiratory actually have much more stringent requirement. This is originally for professionals like construction workers, like painters, etc. But during this pandemic, has been also widely used for medical, for this the coronavirus protection. Surgical mask. There are some more. There are actually many different categories. These are the major classifications. If we look at the structure, if you look at the structure of face masks, Normally they are like this. Normally they are like this. But these are span bonded fabrics. They are made of fibers. Why fibers? Because you see, fibers can provide a lot of pores. These pores can be used for breathability and for filtration. This are bigger pores. You know, there are some spots here. This representing the bonding points, so that the loose fibers can be bonded together to provide stability, to provide strength. And here you can see these are the melt blown. Their fibers are very tiny. Fibers are very small, and then when they are deposited together to form very dense, the web, and you know, because of the high surface area, this you know, the particles and the bacterial droplets can be prevented. So there are, if we look at the melt blown fabrics, this is the key protective material for face masks. And the very smaller magnification, they are quite dense. If you magnify them, they become like this. Okay, this is their microscopic views and different magnifications. So yeah, why melt blown? You have seen some pictures of their structures. The first of all, the melt blown fabric with very tiny, normally can be tiny enough to some micron, but normally 1 to 5 micron fiber diameter. This kind of a material normally has a very low melting temperature. They are simple in process, high productivity, solvent free, and high surface volume ratio, better filtration efficiency. So this is a traditional textile, this span-bound textile. This is the melt blown. They have much higher filtration efficiency. We have tested many types of fabrics. No matter how dense a fabric is, if your fibers in the fabrics are too thick, you cannot get the filtration efficiency properly. At the same time, even though you have melt blown fabrics, they are very fine, they are very tiny, they are very compact, but they still you cannot get sufficient filtration efficiency against the virus and the bacteria, etc. So we normally need to utilize a technology called electric treatment. Here is actually very high voltage electric field with the electrode here, and this electrode can change the structure of the material, and this material and also can add new electrical charges onto the surface. So and with this combination of very fine structure and the electric, the filtration efficiency can be improved. Here actually we compare the structure because the smaller structure can host a lot of more particles, can host a lot of more droplets. So yeah, this is the more detailed structure. There are different types of structure. This is woven, this is lidded, this is the non-woven. First, we use non-woven. Secondly, no matter how close, how solid, how dense are these fabrics, they cannot actually provide the proper protection. Only you have the melt blown fabrics with very tiny diameters. They can actually prevent the penetration of small particles, and of course with the sacrifice of the pressure. The pressure drop representing our breathability. you know, oxygen is our nutrition. Oxygen is our major life element. So the reduction of the air flow to our mouth, to our nose, means the reduction of our probably life quality. And so we have to strike a balance between this. Better to have the very high productivity and very low pressure drop. This is ideal. This is actually the most standard. This is standard. The pressure drop cannot be so high. But in some cases, particularly for those fabrics with this woven knitted structures, they their filtration efficiency can be this, but their pressure drop can be very, very high. So this can be very disastrous. So we need to engineer the structure of the fabrics. So here, you know, the pressure drop, we describe it. You know, in face mask, there are a lot of science. We just see it's a very simple device. It's a textile. Textile sounds not a very high technology sector now, but in fact, this piece of device was not invented by traditional textile factory. Instead, they are invented by very high-tech, very powerful companies like Kimberly-Clark, like 3M, etc. They have combined a lot of knowledge from science, from other disciplines. For example, from environmental sciences. The public health is always related to the environment. Just like Professor Wu presented, environment is one of the most important factors. So the filtering materials is generated to improve the environment we are living. So there are a lot of science in studying the filtration efficiency of a filter. They basically analyze the behavior. They analyze the behavior of different particles, particularly in our air. Say the particle size, if they are in from 0.01 micron to 10 micron, they particularly studied this range of particles. In certain range, for example, from this origin to this 10 micron, the particles in this area normally just have the diffusion. They depends on the principle of diffusion. Diffusion actually resulted from the micron Brownian movement. So we need to use different mechanisms to attract this kind of particles than there. For example, when the particle size is very big, the very small the smaller pore size can actually stop it. So the particle can settling on the mask, on the filters, and here if the particle size within this range, they normally produce impaction on the filters. Here there's inertial impaction. If the particle size further smaller than this range, and then they can have intersection. The intersection, you know, here. So we need based on this discovery, these principles, we design maskers. In this part we use the electric charge. We use the electric charge to attract it. That's why we actually normally don't actually measure this part. Instead, we measure this part. We measure the particle size smaller than 0.1, and then we can we can ensure all this kind of particles can be stopped. We can be actually protected. Yeah, the efficiency of the media. That's why we can have we have to add electric charge. We have mentioned that electric charge is very, very critical. This is a very big discovery. This is a very big invention in protecting us for this pandemic. So we, in order to accommodate the local industry's requirement and also to tell the general public in Hong Kong, we carry out a lot of testing. For example, we got many samples from markets and from maybe our collaborators. We measured the diameters. Diameter is the most important parameter to determine the structure of the face mask, and it's core material for the face mask. This is the melt blown. We collect the melt blown fabrics, and then we measure the melt blown structures. This is this one. This is Japan. This is from Japan. This is a very good. This is a very good sample. You know, their diameter is 2.4 micron. This is almost ideal. This one is also good. This also is not so bad. This one is reaching the margin, the 5 microns. But this one actually much higher than the ideal structure. So actually, in the market, a lot of masks don't really meet the requirement. But this one may be from abnormal. We particularly use it for our reference. And also, pore sizes is very critical for the pore size is very critical. For stopping the penetration of particles, droplets, aerosols. So we measure the pore size of different structures. Can you see? Japanese, the pore size is 12 microns, something, 12 microns, and you can see some of them are very big. Actually, this is not normal mask. This is a fake mask. They don't have the melt blown fabrics there. But this do exist in market. So we have to be very careful that there are a lot of face masks on the market, particularly in the early stage of the pandemic. Now it becomes less and less, but it's still not 100% zero. So there are different kinds. This one is also marginal. This is marginal. Over this one is not very good. You know, can you see from this figure is 12 microns? 12 micron is very big. Even the 10 micron particles can be stopped. However, you know, this it's that we can stop even 0.01 particles. This is because the function of electric. So the electric is extremely important. Without the electric, even the best mask cannot help us. So the technology, material technology, has played a very important role for protecting us. So density of mask. Actually, the lighter the mask is, the more comfortable, because the lighter the face mask is, you know, is softer, can be lighter, so that it can be more flexible. You can speak, you can talk, you can smile. So it's much more stable. It's much more better protected. However, in the market, there are still a lot of masks. They have very heavy density. This is actually to compensate the heavy structure of the diameters. So this is not very good. The heavy ones can be very harmful for our breathing. Okay, the electric. And the electric, probably the more the better. However, the electric can disappear. For example, some of the muskets don't have electric. First, the electric is very important. Secondly, a lot of fabrics don't have the electric charge. Some of them has very high. These are very newly made mask and very newly made the muskets. So you can see there, in general, there are electric for many fabrics, but there are also some muskets very dangerous. They don't have muskets. They don't have the electric. There's from the electric charges function point of view, it's very dangerous. Okay, yeah, we have some more testing. This has more samples. Still, there are various level of electric charges. This is particle filtration efficiency. Particle filtration efficiency is the first standard for. It's the first standard parameter for the filtration performance of a face mask. You can see particle filtration efficiency for this one. This actually fake mask. First, they don't have the filtration material. You can see their filtration efficiency, particle filtration efficiency is very low. There are almost no protection. And some of them has a very good filtration efficiency. However, in the market, there are still a lot of substandard masks. Their filtration efficiency is very low. And this the particle filtration. We have more. We have a lot of many. We tested many samples. This is a much wider area. You can see the particle filtration efficiency is also varying. And then the pressure drop. Pressure drop determines our comfort. It probably determines the quality of breathing, and then the health, the living. This is fake. This is a fake sample. This is a fake sample. The pressure drop, of course, is close to zero, and there's some of them are close to the standard, but some, see some fabrics, some face masks has a very high pressure drop. This can make people suffocating, can be suffocated. This is very dangerous. Okay. So air permeability is related to maybe pressure drop, but this is more direct parameter to demonstrate the air we can breathe. The air permeability for some of them is very low, but this one is very high, but has no protection. And we have tested different types of fabrics. In general, probably the N99 can perform the best. N95 can perform normally, but some of the fabrics, for example, cloth, that's long no woven. This is just a woven fabrics. They have very low filtration efficiency if we measure this against the standard. Here, there's a very complicated relationship between the, here is the particle, this is filtration efficiency, this is a pressure drop. Pressure drop, the blue line is pressure drop, the red line is the particle filtration efficiency. You can see the electric and we also electric. They have very complicated relations. What we desire is high filtration efficiency, for example, here. And we can see here the high electric treatment can lead to high particle filtration efficiency. And now we need to have low pressure drop. This one, this one can actually reach our target. So others, for example, here as the pressure drop. Pressure drop is high here. Particularly here, pressure drop is very high, and the filtration efficiency is certainly substandard. Is also very risky. So this is not good. So we can see that there are a lot of things we need to control. There are a lot of things we need to really investigate. The diameter, can you see the yeah, we investigated the relationship between the different parameters. The diameter, can you see the bigger diameter, the air permeability is bigger, but the air permeability is good. However, the pressure drop, the pressure drop may not be good. And after, you know, after this the initial stage of pandemic, and now if in market you can see so many different types of face masks or respirator masks available in the market. So we need to really consider, the issues, you know, the health impact of the respiratory masks. For example, there are so many factors contributing to the quality performance of the respiratory mask, contributing to the benefit or harms can be caused to our human health. You know, these are all the factors. We need to consider toxicity of the materials. Some face masks have the antibacterial activities. Certainly, they need to add chemicals, or they have different processing to add chemicals. This can cause a lot of threat to toxicity. And then ergonomics, whether it fits, whether it's fit to different sizes of faces, different contour of the faces. It's ergonomics. And then the comfort. The comfort can be related to the air permeability, to the thermal balance, to the water permeability, etc. And then reusability. Your reusability for it's important for many things, particularly in the early stage. You know, we have the shortage of mask supply, so everybody wants to reuse it. And actually, even now we have so many masks on the market, but the problems with the mask is that it's damage to the environment. It's the threat to our environment, because there's so many pollution can be caused to our soil, to our air, to our water, etc. You can see here there are, you know, you have found the data. The sweat, when we wear the mask, we can lose 50% of the water hailing out, and then we can also have the air loss, can up to 90% of air loss. We can also, we may lock some bacteria from within our mouth, our lungs. So this can cause also danger to our health. And heat loss. Yeah, when we cover our mouth and the nose, we have a lot of heat actually stopped from spreading. So there are a lot of problems. There's a lot of changes caused by wearing the mask. They can cause so many problems, even death. You know. In order to solve these problems, maybe people have not totally realized the statistical, statistically the harmness to the harm to our body. And there are different types of methods to improve. For example, we can use wool materials. It said wool materials can be antibacterial, can keep us comfort, and can also avoid some kind of toxicity. And wear mask, in addition to the problems I have already mentioned, for some people, it's essential to use our mouths. For example, for those deafs, they use their mouths to communicate. So there is need of transparent um, uh, masks. So there are a lot of leads for improvement uh, for the sort of understanding and for the alterations of our daily wearing masks in this pandemic. We still do not know when the pandemic can go. It seems that it's coming back with a stronger impact and a stronger influence. So we we need to really make a lot of more effort. The mosque is small, but its impact is very big. So just the one, new technologies require innovations are required for more and better economic. Comfort healthcare become very urgent. This is because pandemics is really needs face masks, and a lot of masks in the market do not meet the standards. Okay, and that's all from me. Thank you very much for your attention.
Thank you, Professor. Thank you, Professor. Thank you so much for your stimulating speech. Sometimes the simplest things means a lot, and your presentation regarding the COVID-19 and the masks and regarding the present situation, it helps us a lot. So I'll leave some time here. If anyone have any comments or questions, you can please ask Professor Wu from the University of Hong Kong.